Welcome to the Peacademia course on the basics of semiconductors. This lecture covers the junction capacitance. Let's start. By the time you finish this lesson, you will learn the voltage-dependent junction capacitance and the application of the junction capacitance. Another topic to talk about when dealing with the PN junction is the junction capacitance. As we have seen this a lot, three scenarios can be considered when thinking about biasing a diode: reverse bias, unbiased, and forward bias. Under different biasing scenarios and voltage applied, the width of the depletion region gets smaller or bigger. From reverse to forward biasing, the depletion region width gets smaller and smaller. The depletion region is free from any mobile charge carriers. At the edges of the depletion region, we have the accumulation of minority charge carriers. Therefore, you can imagine the edges of the depletion region as two facing conducting plates, which are separated by the depletion region. Soon we can realize that this is nothing but a capacitor that has a specific capacitance. If I assume that the capacitance of the diode under the reverse bias is E sub JR, I can say that the junction capacitance when the diode is not biased is C sub JU. Since the space between the edges of the depletion region is shorter, when the diode is not biased, CJU is larger than CJR. Consequently, moving toward the forward bias, the depletion region becomes smaller and therefore the junction capacitance gets even bigger. If the impurity concentration of one of the semiconductors in a PN junction is much larger than another one, the PN junction is called one-sided. If I assume that the diode depicted here is one-sided in a way that the concentration of the acceptors of the P semiconductor Na is much larger than the concentration of donors of the N semiconductor, indeed, the junction capacitance of the diode can be calculated using this equation. In this equation, Q is the charge of an electron, epsilon is the permittivity of the base semiconductor, Nd is the donor concentration of the N semiconductor, Vbi is the built-in voltage, and Vr is the reverse voltage applied to the diode. Just as a reminder, permittivity equals the relative permittivity times the permittivity of the vacuum. By the way, to show that the diode depicted is one-sided, we need to add a plus sign right after the P to show that Na is much larger than Nd. Now, let's take a closer look at the junction capacitance by plotting the normalized junction capacitance versus the reverse voltage. This plot is evidence that by increasing the reverse voltage, the junction capacitance reduces. In some applications, for example, when the resonant frequency tuning is required in analog circuits, the junction capacitance plays a very important role. This is because by changing the reverse voltage over the diode, the capacitance is changed. If this capacitance is part of a resonating circuit, the resonant frequency is accordingly tuned. There are some special diodes called varactors used for this particular purpose. The name varactor is coming from the fusion of the words variable and capacitor. By manipulating the junction capacitance equation, we can come up with the reversed capacitance squared equation. Let's plot this equation versus Vr to see what we can get out of it. This is a linear plot with a slope of 2 over q epsilon Nd. What this plot tells us is the fact that the slope of the diagram is determined by the donor dopant concentration. Q and epsilon are constants. So, if I give you a diode and ask you to tell me what the concentration of the donors is, what would you do? I wait for a few seconds, giving you some time to think about it. Alright, Let me give you the answer. What you could do is to look at the datasheet of the diode. In the datasheet, you should be able to see the junction capacitance versus the reverse voltage plot. Using this plot, you can simply calculate the concentration of the donor concentration. In this lecture, I discussed the junction capacitance of the PN junction when biased reversely. In the next lecture, I'm going to explain the transient behavior of the PN junction from forward to reverse biasing and the reverse recovery. Thanks for joining this lecture of Peacademia.